We defined different types of master problems that we felt were key to our success and key to the way we should approach development of a project of this nature.
The first master problem was the player movement.
The second master problem is passing.
The third was about player interaction.
Master problem 4. It's all around player orchestration.
In the winter of 2020, we had a lot of things built, and we were starting to put various systems together. Once we did, we saw football happening, and we were very happy.
Yes, we were.
Yeah.
Extremely happy.
Extremely. It was very close to real football, but it was not there yet, and it was in the area that we call the Uncanny Valley. It's very close. Very close, but it's still slightly off. So we started analyzing, and we spent multiple weeks, I think, looking at it. We wanted to figure out what were the root causes of the issues that we were seeing. It's easy to look at the football happening and only see the symptoms, but we needed the root causes.
In such a project, the best approach is really to try and break this thing down into some kind of more approachable pieces. You can analyze them in a way that allows you to eliminate or demystify some of those unknowns as soon as possible. This type of approach we eventually labeled master problem sets.
So the master problems were player movement, passing and receiving the ball, player interaction or player-to-player contact, and player orchestration.
As you can see, they're listed in a specific order because they go from concerning just how one player moves to concerning how two players are going to pass and receive the ball to,
in the end, orchestrating the whole team to converge on a certain situation.
The player movement is important for two reasons. First, it's something that the users actually see all the time, so it needs to look nice. Secondly, the movement is handled by the animation system, which means that the animation system is ultimately responsible for where the players can go and what they can do. This means that, for example, the AI cannot just simply decide to do something and just do it. It needs to first ask the animation system if this is possible and what it would look like if that was something to be done. For example, the AI system will ask, hey, I want to get to that ball. Can you tell me is that possible? And then the animation system would say, yeah, you can get to the ball in like 3 seconds. Then AI would make many queries like this, and then the AI would decide which options makes the most sense. Animation system basically works by playing a lot of short animation clips in sequence. These short clips will represent like some of the very basic layer motions like running or turning or kicking the ball. And then these are sequenced properly, so play in a correct order, so that we get a smooth motion of all the players.
When we want to add a new feature, say headers, we will think about the sequence of movements that we would like, and then we would break that down into sufficiently short animation clips. And then we would go grab our motion capture equipment, rent a room, grab one of the football players around here, and record those clips. Then we would repeat that process until we're satisfied with the raw animation clips that we've got. And then that goes through our automatic asset conditioning pipeline in the engine, and then is selected by the system during the simulation to be planed and chained together.
Well, the biggest challenge for me was to kind of create the system that performs the motions of the players in a way that's natural. So this is something that humans generally learn very early in an early age. When they do it, they don't really think about it. We had to really go deep and try to figure out how it is the humans do it. So it was interesting because we would often have football players on the pitch, and we would ask them about something, how would you do this, or how would you perform this action, and they couldn't explain it. They would have to try it actually with the ball, and only then would it happen like instinctively. The animation selection system. This is a system that decides which animation to actually play. Currently, we have a lot of animations, and with each system, we would add more, and then that system would break down. So we go back to the drawing board, try to figure out how to improve it based on our learnings using it. We organized the mocap sessions ourselves. We hired some number of football players to be the actors. We had an audition where we chose the players that fit what's needed for us the most. We wanted to have some players that have a very natural moment and not some characteristic trait that sticks out. And then we would schedule and we would plan the mocap session where we record a bunch of moves. mouse. So basically, we rent a venue, football pitch basically. We schedule time with the football player, the actor. We get him into the equipment, the motion capture suit, which captures his performance. And then we basically go through the animation list that we planned for that day. So, and for each animation, we have several takes until we get the performance that we want. And then once we go through the list, that's done.
Then the animators would take that raw motion capture data and retarget those skeletons to the skeletons that we need, and they would give it a little bit of polish, basically work that needs to be done to get like rough mocap into something that's usable and animation clips that you can actually link together and that link together seamlessly. That's really important. Otherwise, you would see stuttering when moving from run to sprint or something like that.
First step of animation process is that game designers decide which feature they want to implement next in the game. We group all the animations in separate branches like kicks, tackles, or so on. Then we decide which groups we will shoot on which day. Next step is that we go online and search as many references as we can. And next step is that go on the pitch and film everything we need. After filming, when we are satisfied with everything we got, we go back to the office and process all the takes. We edit every file. Editing process is like getting rid of the glitches, of noise, of everything, and we got a few weeks after to work on those files until they are ready to go in the game. In the end of the whole process, we try to figure out how to put everything from real life in the football game and in Football Engine.
I'm very happy with what we have now. It's really simple and readable, and it's also very scalable. It can support a lot of animation, so we're set for the future, I think.
Out of all the stuff, like Football Engine, football, there's like gazillion of those systems and moves and everything, but the passing is the most complex one. So you have this guy who has the ball, he wants to pass, he has to look how the field to signal to his friends to look where all the opponents are so he doesn't get intercepted. Then they need to orchestrate and avoid all the problems. It was very challenging because it also needed a lot of orchestration between all these animations and the AI. At that point, we had to re-architecture like the whole system so this could work. And when we got that, when we got passing, everything else was much, much easier. At the point when we started it, there was some AI system that was doing passing, there were some animations that were doing passing their own way. It could do something, but it couldn't do all the things we needed to do. We have brains that can do it, but for computer it's all very complicated. It's also the most expensive one for the performance, so we had to do some shortcuts. And so that at one point there was, okay, so we have all those 20, 50, 100, I don't know even how much attempts. And then for all those, then we needed to do, okay, there's this 10 opponents and they also have to try to intercept this. The interceptors, we had to do some AI, actual, machine learning AI that could try to solve the intercepts.
Player interaction is mostly about the behavior of players that are making physical contact or are about to make physical contact. It brings a new level of fidelity when you create a computer game that simulates real football. Without it, it wouldn't look natural. We have to keep in mind that players make moves that are very dynamic. And since several players are potentially involved, that could lead to somebody get hurt. So we needed to figure out ways of working with actors when capturing their emotion and still avoiding them or their assistants getting hurt or the equipment getting damaged. We have several players in contact at a given moment, so we needed to find creative ways of making a believable and a plausible situation in football using just one equipment for motion capture.
Finally, master problem 4. It was not a single issue that we were trying to solve, it was multiple problems. It's how these players are behaving as a team. How are they respecting the formation, the tactics? How would they listen to what manager wants from them to do? It was pretty challenging because when some issues occur, you basically are not sure what is the root cause of that issue. So we developed a lot of systems around team behavior and player orchestration, so we can track, monitor, and easily detect what was the main source of our problem.
Our goal here was to make them behave as an intelligent unit, as an intelligent team, and in that sense we wanted them to build together something that the manager set up as a tactic for the team, like for them to do the attacking maneuvers, to do the defensive maneuvers, to execute man marking in a more intense fashion, to do more attacking runs if you're attacking, things like that basically. And that was an additional layer in the system inside of our engine. For us to implement these team-based behaviors of executing these tactics was a challenging problem from an algorithmic level side of things, but also on the football level side of things, and to connect everything together inside of the engine while the engine is being developed actively.
Sometimes things happen. We're watching team orchestrate and perform some actions, but we're like, what is happening? Why are they doing that? We didn't tell them. So at that point, like, going deep into the code and debugging and finding like root cause of what are the actual issues is pretty complex things, because you're not just going through decisions of a single player, but you have to drill deep and find whether something on the team level caused that this player behaves in a certain way.
There are many moments where a pass would not happen and the person watching the simulation would expect it to happen. There are many moments like that in the engine, and we had to develop quite extensive set of tools to handle this problem, because we need to be able that basically in every frame of the engine to stop the thing and see what's happening and who's doing what inside of the system. And we invested a lot in football engine tooling in the last couple of years.
So there are the opposite moments, call them what moments, and there like something amazing happens and we are like, when did we make this? But actually what's happening is that that player orchestration thing is created in such a general way that you have quite a variety of actions happening and supported. And sometimes it can happen to that players orchestrate in such a good way that actually it resembles some of the plays of other great teams. That times like we don't hesitate, we take all the credit and like move on, yeah.
There is a huge amount of devices on which top 11 is being played, and there are about 25,000 of devices, different configurations of devices.
How can we put 3D in top 11 and make it so that everything is still fun for our players?